In this lesson, we're looking at data that's represented on a scatter plot without a linear equation, but we're using the concept of line of best fit to estimate a linear relationship between the two variables that's represented on a scatter plot. So starting with this example here, our goal when we are drawing our line of best fit is to have roughly the same amount of data points below and above the line that we're drawing. We cannot be too precise with this one, so we're approximating our line, but we try our best to be as close as possible. So if we draw a line somewhere along here, although it looks like it's sort of middle of the data, you can see there's more data points that are above the line than below the line. So we want to sort of make sure that we are separating it halfway. I think this is more like it. Now we have 4 above the line, 4 below the line. So that's going to be our line of best fit. This next one here, again, we just be very careful so that we draw a line. It's not very good, so we'll try again. Draw a line maybe this way, so we have about half above and half below. This one's going to be a bit harder, but we're sort of estimating. I don't think that was very good. It's more here that we have about half below, half above. And the last one as well, probably somewhere around here, so we're half below and half above. So by doing this, even though we're not given a linear equation to represent this relationship, by estimating this line, we can sort of use this line to see the relationship between the two variables, as well as make some predictions for the future. So let's have a look at this example here. We're looking at velocity, speed, and time of something, I guess that's been moving. It's a car. So yeah, and in this case, we're given these data points, all these dots, as well as a line that goes through in the middle. That's the line of best fit. And the question asks, what is the car's velocity when time is at 0? Then we look at time at 0 right here, and we're looking at the velocity here. That's going to be around, I would say, 18. And the unit that's given to us, it's millimeters per second. So we write the unit there as well. The next question says, what is the slope of the line? So when we deal with line of best fit, it's same as dealing with any linear line that we've dealt with. So to find slope, we need 2 points on the line, and as you can see, not all the points are on the line, so you want to make sure you're picking the points that are on the line, or mostly on the line. Like this one's okay, and this one's also okay. And obviously to find the slope, we're doing rise over run, or we're doing y2 minus y1 over x2 minus x1. So if we label these points, x, and the y value here is around 25, and let's do this one at 0, 18, and we substitute the values in. So I'll go 25 minus 18, 5 minus 0, 7 over 5 is our gradient, the slope of this line. The last question says, write down the equation of the line. Again, it's the same skill as before. We know our equation has to look like this, but we know our gradient already. We found that. So this is our equation at the moment. So to find A, you just need to substitute one of the points. I'm going to substitute 0, 18. Then you have 0 instead of y equals a plus 7 over 5 instead of x, I have it the other way around. Instead of x, we have 0. Instead of y, we have 18. And you can put this in the CAS and use the solve function to solve for a, and it'll give you a right away. Or you could just realize a has to equal 18 here. So our equation is y equals 18 plus 7 on 5x. Now, if I given this as our final answer, I would not get full marks for this one, because as I highlighted here, it says write the equation in terms of velocity and time. And as you can see on our graph, velocity is our y, time is our x. So instead of writing x and y, we can write velocity equals 18 plus 7 over 5. And instead of x, we write time. So that'll be the final answer. Alright, this next equation looks at student staff ratio for secondary schools and primary schools on this side. And it's asked to find the equation in terms of the variables in the question. So the variables in this question are these two. These two are the variables, x and y. And we're asked to find the equation for it. Now, to find the equation of this linear line, we need 2 points that are on the graph. And this is a little bit of a tricky one. We'll have to estimate these values, but let's do this one first. I would say that's not quite 19, but halfway between 18 and 19. So maybe 18.5. And for the y value, it's a bit less than 17, so it'll probably be 17.5. So that's our first point. And pick another point on the line, this one here. It's not quite 13 for the x value. So probably like 12. Sorry, not quite 14 on the x value, but more than 13. So 13.5. And for the y value, it's just below 12, so maybe 11.5. So we're estimating a little bit, but these values are fairly close to the real values. Now, once we have these 2 points, we can make up 2 equations. So y equals a plus bx. Equation 1, we will make by substituting these 2 values. So a plus b times 13.5. And the other equation, let's substitute these 2 values. So we have 17.5 equals a plus b times 18.5. Now, when we have 2 equations and we have our 2 unknowns, a and b, and we need those a and b for our actual equation, we go to the CAS calculator, menu, algebra, solve system of equations, and our variables here will be a and b. And all you need to do now is type in the equations. So if we go 11.5, actually I'll skip it. Alright, so I've just typed everything in as we've written it here and pressed enter, and it's given us false. So this might happen to you as well. So what's happening here, so I'm just going to copy this whole thing back by going up and highlight this thing I want and pressing enter. It will just copy the whole thing over so I can edit it a little bit. So what's happening here is that when sometimes we put letters and numbers next to each other like this, it doesn't register as there's a times in between. So you might need to add that as well. And let's see what happens now. Yep, so now it's all good. It's given us the A and the B value. So obviously you copy those down, negative 4.7 and 1.2. And our final step, actually second final step, would be writing our equation in terms of x and y. And our real final step would be writing it in terms of the variables. So, oh, that's a long thing to write. So I might just call it secondary for y. So the staff and student ratio in the secondary schools. And for the x variable, let's call it primary times the primary. So that will be the final answer.